Have you ever gazed up at the night sky and wondered, where did all this come from? The desire to understand our cosmic origins is not just scientific curiosity, it's a deeply human pursuit, a yearning to decipher the cryptic narrative etched across the cosmos. It's about tracing the breadcrumbs of cosmic evolution back to that first spark, that initial explosion of everything we know. In our quest to understand our place in the universe, we must first explore its birth. Imagine everything in the universe, all the stars, galaxies, and matter compressed into an incredibly small, dense, and hot point. Yes, that's right. We're talking about the Big Bang Theory, the leading explanation for how our universe began. This theory suggests that around 13.8 billion years ago, everything we know in the universe was squeezed into a tiny, hot, dense point, or singularity. This singularity was not located inside of anything, not in space, because there was no space. It was all there was, and then in a fraction of a second it began to expand rapidly. In that moment, the Big Bang happened and our universe was born. The Big Bang wasn't an explosion in the sense we usually think. It was an explosion of space itself, and it's still happening today. The universe is still expanding, and at an accelerating rate too. So how do we know all this? Well, there's quite a bit of evidence supporting the Big Bang Theory. For one, we have the redshift of galaxies. When we look at distant galaxies, we see that their light is shifted towards the red end of the spectrum, indicating that they're moving away from us. This suggests that the universe is indeed expanding. Then there's the cosmic microwave background radiation. This is the afterglow of the Big Bang, a faint whisper of radiation that permeates the entire universe. It was first detected in the mid-20th century and has been studied extensively since. It provides a snapshot of the universe just a few 100,000 years after the Big Bang, further supporting the idea that our universe started from a hot, dense state. From this violent explosion, the universe as we know it began to form. The Big Bang Theory is our best attempt to explain the origins of the universe, a testament to human curiosity and our drive to understand the cosmos. But remember, it's just that, a theory. As we continue to explore and learn, who knows what other fascinating secrets the universe may reveal. As the universe expanded and cooled, matter began to clump together under the influence of gravity. This was the beginning of a cosmic dance that would eventually give birth to galaxies, those sprawling cosmic cities we see scattered across the night sky. Picture this. In the early universe, particles of matter were drawn towards each other by gravity. These particles began to form clumps like cosmic dust bunnies under a universal bed. Over time, these clumps of matter grew larger and more complex, eventually forming what we now recognize as galaxies. But it wasn't just ordinary matter playing a part in this production. Enter dark matter, the mysterious and unseen substance that makes up about 85% of the matter in the universe. Dark matter, though invisible to our eyes and telescopes, exerts a gravitational pull. It acted like a cosmic scaffolding, helping to shape and hold together the galaxies. And oh, what galaxies they are. From spirals to ellipticals, from lenticulars to irregulars, each galaxy is a unique masterpiece. Spiral galaxies, like our own Milky Way, are characterized by their swirling arms of stars and gas. Elliptical galaxies, on the other hand, are more like cosmic footballs, filled with old stars and very little gas or dust. Lenticular galaxies are a hybrid of sorts, blending features of both spirals and ellipticals. And then there are the irregular galaxies, the rebels of the universe, who don't fit into any neat category. These galaxies, with their billions of stars, are more than just beautiful spectacles. They're the building blocks of the universe, the cosmic neighborhoods where stars are born, live, and die. They're where elements are forged in the heart of stars and scattered across the cosmos, eventually forming new stars, planets, and even life. So the next time you gaze up at the night sky, remember you're looking at the result of billions of years of cosmic evolution. These galaxies, swirling masses of stars and cosmic dust, are the building blocks of our universe. Around 4.6 billion years ago, within the confines of a galaxy we now call the Milky Way, our solar system was born. Picture a vast, cold cloud of gas and dust floating in the cosmic void. This cloud, or nebula, was the cradle of our solar system. Over time, the pull of gravity began to work its magic on this nebula. It nudged particles closer together, causing the cloud to collapse inward upon itself. The heart of the nebula grew dense and hot, and in this fiery crucible our sun sparked to life. But what about the planets, our Earth included? Well, they formed from the disk of material that swirled around the newborn sun. Tiny particles of dust and ice stuck together, slowly building up into larger and larger clumps. Over millions of years, these clumps grew into the planets we know today. Our solar system is unique in many ways. It's a balanced mix of rocky planets close to the sun and gas giants further out. It's home to a planet with liquid water and life, Earth. And it's the only place we know of with a planet like Jupiter, whose mighty gravity protects the inner planets from too many comet impacts. And thus, our little corner of the universe, our solar system, came into being. As we gaze upon the stars, we are looking back in time, witnessing the cosmic history of the universe. We've journeyed from the explosive birth of the universe in the Big Bang, through the formation of galaxies, to the creation of our very own solar system. Each of these stages, a significant chapter in the cosmic storybook, offers us a glimpse into our celestial roots, reminding us of our humble place in the cosmos. It's a fascinating journey, one that underscores the importance of curiosity and the relentless pursuit of knowledge. Now, I pose a question to you. How do you think the universe will end? Comment your answer below. I'll pin the most interesting response. Don't forget to like, subscribe, and share this video with your friends for more content like this. Keep exploring, keep wondering, and keep learning, because the universe is full of mysteries waiting to be unraveled.